Hi everyone. In this lecture, I will tell you how you can convert your data structure that we have written in the last lecture into a header file. We will put this code into a header file, and later on for multiple programs, we can reuse this code by importing this header file. Okay, so what we are going to do, we are going to cut this code apart from the main part, because in the main we are using this. So I'll create a new file. I will call it as vector.h. So .h is for header file. So we have created a user defined header file, and here instead of importing the vector from the standard template library, okay, so a standard template library import would have angular brackets, but if you want to use your own library, so it is vector.h. okay. So this header file is written by us. We are going to import it, and the import is successful. I've tried building the code and it works. Okay, so we have vector v, so everything is going to remain same. The only thing is now the code is moved into a header file. Okay, and you can include this file in any of the files for which you want to do the code, but the only thing is you should give the correct path. Now it is in the same directory, so we are able to use the relative path, which is vector.h. And let's build the code and let us try to run the code. So /vector, again we are getting the same output. Now you may ask, when we actually saw the demo of using the STL, we actually created a vector like this. We created a vector with a small v. That is the class name, because we used a capital name, but STL uses a small name. Okay, so this is a new file. Okay, this is a new file. If I try to show it to you here, okay, so we are in this vector.h. This is vector.h and this is vector.cpp. So yeah, so when you created a vector, you saw you can create a vector of integers like this. You can also create a vector of booleans like this, or maybe you can create a vector of students like this, but our code will not work. So we have to make it generic also, so that it can support all the data types. Okay, now let us see how we can make our container a generic container. And here we will talk about a concept of templates, how we can use templates to make our data structure more powerful, so that it works with all the possible data types. Okay, so I'm going to convert this code into templated code, and let's follow the steps what I'm going to do. So first of all, I'm going to tell this class that you are a generic class. Okay, so I'm going to define a template type name t. This is the way using which C++ tells this class, okay, all the data will be of the type t, and this type t will be supplied by main or where this data structure is used. Okay, so t is some generic type. You can have x, y, z, anything. Okay, we are telling the data in this class would contain objects of type t. That means your array that you're creating, an array of integers, this now should be of the type t. Okay, so t is some generic data type which would be defined later. Okay, it could be student, it could be int, it could be bool, anything. So this array should be of the type t, an array pointer, and current size will remain same, max size will remain same, because they are integers. And here this would be of the type t, and we will have pushback function. This data would be of the type t. The old array pointer would be of the type t. This new array would be of the type t. That's it. What else we need to change? And this is also fine. The return type would be type t. For this would return an element of type t. The back function would be of type t. The front function would be of the type t. And I think we are done. Okay, so apart from it, we don't need to make any changes. But now what has happened is, our library can create this vector for any data type. Now you can create a vector of students, vector of books, vector of booleans, vector of integers. But if I build this code, this is not going to run, because this vector type is not complete. It doesn't know what type of vector to make. So you will define in angular brackets, no, this is a vector of integers. Okay, so if I run this code now, you can see we are getting the right output. So that means we are able to make a library of a vector very similar to that we have in C++ STL as well. And if I want to make a vector of, let's say, characters, I can do that as well using the same data structure. Okay, so I can say vector of vector VC, and I can say VC dot pushback A and VC dot pushback B, and I can iterate over for some character C that is there in VC. I can say cout, or let me just do it like this. Okay, we need to do some extra work to support this kind of a loop. So for now we can say int I equals to 0, I less than VC dot size I plus plus. I can say print VC of I. We will see A, B, C, whatever we have here. Let's build the code and try to run it. Now you can see the same data structure class can be used to implement vectors of different data types. That is the idea of generic programming in C++, and it is achieved using this syntax of templates. So I hope you got a bit idea about templates and how you can make your classes more generic and work for different data types. That's all for this lecture. Thank you.